guys, it's Eddie the Magic Monk. Today we're going to talk about the binomial distribution. The binomial distribution is used when in an experiment we can classify the result of each trial as a success or a failure. For example, if we take a shot in basketball, the shot is either in or out. Let's define success as getting the shot in and failure as missing the shot. Now I'm going to make up another variable called P and Q. P stands for the probability of success and Q stands for probability of failure. Now I'm going to pretend that you are a pro basketball player and you have a probability of success of 0.8 and a probability of failure of 0.2. Once we have defined the probability of success and probability of failure, we can then come up with some questions about this binomial distribution. We can say that if you took 3 shots, what is the probability of you getting all 3 shots in? Now, if you guys remember probability lesson 3 where we talked about independent events, the probability of getting all 3 shots in would be P times P times P, which is 0.8 times 0.8 times 0.8, which is 0.512. Now, if I asked you what is the probability of you missing all 3 shots, then to work that out, you would do probability of missing 3 shots equals Q times Q times Q, which is Q to the power of 3, which is 0.2 to the power of 3, which we have discussed earlier. Probability of failure is 0.2. So 0.2 to the power of 3, which is 0.008. So we have the probability of getting all 3 shots in. We've got the probability of missing 3 shots. So let's put all that information in a table. So this table shows all the possible results from our experiment of taking 3 shots in the game. So the probability of getting all 3 shots in, we have said, is 0.512. And the probability of missing all 3 shots is 0.008. So what is the probability of getting 1 shot in? And what is the probability of getting 2 shots in? So let's do these ones individually. So the probability of getting 1 shot in, now you might say, well, that's just the probability, that's just P, Q, Q, right? Because you're getting 1 shot in, so that's 0.8. You're missing 2 shots, so you're going to go 0.8. That's the probability of getting the first shot in times 0.2 times 0.2. But what you didn't realize is that there are a lot of other situations. So you could also go you could also go QPQ, because you could be getting the first shot in and the other 2 shots you missed, or you could be missing your first shot and getting the second shot in and missing the third shot, or you could be getting 2 shots missed and getting the third shot in. So there are actually 3 possibilities. So when there are 3 possibilities, you need to get the probability of each one and you then need to add them together. So it's going to be 0.8 times 0.2 times 0.2 plus 0.2 times 0.8 times 0.2 plus 0.2 times 0.2 times 0.8. And what have we realized? That these three numbers all give you the same result, because PQQ, probability of success times probability of failure times probability of failure, it doesn't matter which order you multiply them in, you're going to get the same answer. So if you find the answer to one of them, which is 0.032, you can simply multiply that by 3 and you'll get the answer of 0.096. So we have 0.096, we can fill that in. And then the last one remaining is the probability of getting 2 shots in. So let's do that. So probability of 2 shots in is going to be PPQ plus PQP plus QPP, and that's going to be again 0.8 times 0.8 times 0.2. Now, because you know that these three are going to be the same, so it's just going to be 3 times that. So notice how we're shortening it each time, and pretty soon we're going to make up the formula. So the answer for that is 0.128. Multiply it by 3 and the answer is 0.384. So let's put that into our table. Now, what do you notice about these probabilities is that they should add up to 1. So let's do a quick test. 0.008 plus 0.096 plus 0.384 plus 0.512, and the answer is 1. So we have just completed our binomial probability distribution, where we have distributed the probability for all the possible results in our experiment.